Like the majority of the systems on the A330, the air conditioning system is fully automatic and is designed to provide a comfortable atmosphere for working and travelling. We will begin our study of the system by first looking at the air conditioning packs. The A330 is equipped with two air conditioning packs located in the wing root area forward of the landing gear bay. Let's look at how a pack works. Hot bleed air enters the pack via a pack flow control valve. The purpose of this valve is to adjust the flow rate through the pack. The air then passes through several stages within the pack, heat exchangers and air cycle machine, so that it is cooled to provide a conditioned air output. In fact, sub-zero temperatures can be achieved. The flow of ambient air passes through the heat exchangers to cool the hot bleed air. This flow enters via a pack air inlet flap and exits via a pack air outlet flap. A temperature control valve is fitted and can modify the pack outlet temperature by adding uncooled air to the turbine outlet flow. The pack flow control valve and the temperature control valve are regulated by a pack controller to vary the flow rate and the temperature output. The pack controller also controls the pack air intake and outlet to vary the amount of air passing through the heat exchangers. Note: to avoid ingestion of foreign objects, the inlet and outlet flaps close temporarily during takeoff and landing. To make things simpler, let's define the area within the black box as a pack. The two air conditioning packs operate automatically and independently to provide cool, conditioned air. The conditioned air from the packs is then fed to a mixing unit. In case of failure of both packs, an emergency air supply is provided via a ram air valve to ventilate the cockpit and the cabin or to remove smoke. Various pack parameters are monitored by ECAM. They are pack flow, compressor outlet temperature, temperature control valve position, and pack outlet temperature. These parameters with the valve positions are displayed on the upper part of the ECAM bleed page. Having discussed the air conditioning packs, we will now look at how temperature and flow regulation is achieved throughout the aircraft. The four outputs from the mixing unit feed four separate aircraft zones: the cockpit, the forward cabin, the mid-cabin, and the aft cabin. Let's look at how the temperature of the zones is managed. A zone controller monitors the temperature of the four zones and sends signals to the pack controllers to set the air temperature delivered by the packs. Normally, cold air is delivered by the packs and is then sent to the four zones. Since the different areas of the aircraft may require different amounts of cooling or heating, hot bleed air can be added via trim air valves to achieve the demanded temperature for a zone. These valves are controlled by the zone controller. In the example shown, no hot air is being added to the cockpit and the forward cabin zone. Some hot air is being added to the mid-cabin zone, and a lot of hot air is being added to the aft cabin zone. The trim air valves are supplied via two hot air valves. These valves regulate the pressure of the hot air supplied to the trim air system for optimized temperature regulation. A hot air cross valve is also fitted. It automatically opens when a hot air supply fails. The zone duct temperature, which is the temperature of the air entering a zone, the zone temperature itself, and all of the system valves are monitored by the zone controller. The trim air system, the hot air system, the zone duct temperature, and the zone temperature indications are all displayed on the ECAM conditioning page. The ECAM cruise page also displays the zone temperature indications. The air panel on the overhead panel allows the pilot to control the air conditioning system. Let's look at the controls on this panel in a little more detail. The pack push-button switches control their associated pack flow control valves. The pack flow selector serves to select the desired pack flow. We will look at the use of this selector in more detail during the normal operation module. The guarded ram air push-button switch controls the emergency ram air inlet valve. In the example shown, this valve is closed. The use of the ram air push-button switch is restricted to abnormal conditions and will be discussed later. Each hot air push-button switch controls its respective hot air valve. In the example shown, the valves are open. Now let's look at temperature control. The zone temperature selectors are used to adjust the required temperature for the associated zone, cockpit and cabin. Note, each cabin zone temperature can be modified through the forward attendant panel. Two cabin fans are fitted to reduce the bleed air requirement and therefore save fuel. These fans establish a recirculation flow of air from the cabin zones to the mixing unit. Note, in normal operation, there are no ECAM indications associated with the cabin fans. A cabin fan's push-button switch on the ventilation panel of the overhead panel controls the cabin fans. This push-button switch can be used to switch the fans off in response to an ECAM procedure. We will look at the use of the air conditioning system during a normal flight. As part of the aircraft walk-around, check that the pack inlet and outlet areas are clear of debris and verify the condition of the ram air inlet flap. Let's assume that you are about to start the flight. The APU is running and you require air conditioning. You are now in the cockpit, and this is how you find the air panel during your scanning sequence. Notice that, except for the off lights on the two PAC push-button switches, all the other push-button switches are in the normal lights out position. One of the items in the cockpit pre-flight is to extinguish all white lights on the overhead panel. So that you can watch what is happening, let's have a look at the ECAM bleed page. Call the ECAM bleed page. Now extinguish the PAC 1 off light. For that, you have to switch PAC 1 on. Switch PAC 1 on. Notice that the amber fault light on the PAC 1 push-button switch illuminates because PAC 1 is on, but no bleed air is available. Switch PAC 2 on. As for PAC 1, the amber fault light on the PAC 2 push-button switch illuminates because there is no available bleed air for PAC 2. Notice also that there are no ECAM changes. Since you are expecting a standard passenger load, the PAC flow selector can be set to normal. Set PAC flow to normal. Once again, there are no changes to the ECAM indications. The PAC flow selector only affects the PAC flow rate once the engines are running and supplying bleed air to the PACs. We will look at the use of the PAC flow selector later in this module. It is now time to get some air to the PACs. As the APU is already running, set the APU bleed to on and watch the ECAM indications. Switch APU bleed to on. Both PACs are now providing air conditioning. This is shown by the ECAM page indications and the amber fault lights, which have disappeared on the air panel. On the ECAM bleed page, high flow is automatically selected regardless of the PAC flow selector position, because air is only supplied by the APU. Let's look at temperature regulation of the air conditioning system. This is better seen on the ECAM conditioning page. Call the ECAM conditioning page. Let us concentrate on the upper part of the ECAM conditioning page. Look carefully at the indications. Notice in particular the zone temperatures and the duct inlet temperatures. Temperature regulation is achieved in the same way for all the zones. The cockpit and the cabin zone temperature selectors are in the 12 o'clock position. In this position, a zone temperature of approximately 24 degrees Celsius is demanded. As the 15 degrees Celsius of all the zones is well below the demanded 24 degrees, the zone controller sends a command to increase the amount of hot air added. Due to this command, all the trim air valves open, the zone duct temperatures increase, and so warm air is supplied to the different zones, and the cockpit and the cabin zones start to warm up. In our example, the cockpit zone reaches the demanded temperature before the cabin zones. You can notice that the trim air valve of the cockpit zone closes progressively, reducing the amount of hot air in order to stabilize at the demanded temperature. Once the desired temperature is reached, This valve will move as required to maintain the zone temperature. It is now time to start the engines. So that you can watch what is happening, let's go back to the ECAM bleed page. Note, normally the engine page is displayed during engine start. For training purposes, we will display the bleed page. Call the ECAM bleed page. Let's start the engines. Be sure to watch the pack valves on the ECAM bleed page. Click on either engine. As soon as the engine start sequence begins, the pack valves close. This is to allow all of the APU bleed air to be used to start the engines. Let's complete the sequence. When the engine starting sequence is completed, the pack valves open. The APU bleed supplies the packs. Pack flow high. Note, if either engine start is delayed more than 30 seconds, the packs will come back on automatically. Notice that the engine bleed valves are closed, even with both engines running. This is because the APU bleed has priority over the engine bleed. So, if you were departing from a performance-limited runway, the packs could run from the APU bleed air, resulting in no loss of engine performance, no weight penalty. However, today in our example, the APU is no longer required. Switch off the APU bleed. When the APU bleed push-button switch is selected off, the APU bleed and the cross-bleed valves close. The link lines disappear, and both engine bleed valves open, supplying the packs with bleed air. As you can see on the ECAM bleed page, the pack flow automatically reduces. This is because the engines provide a higher flow rate than the APU. Also notice that the air panel is now in a normal lights out configuration. When the APU is shut down, all the APU indications disappear on the ECAM bleed page. During the flight phase, the air conditioning system will work automatically, and the only pilot input that may be required is to adjust the zone's temperature. Let us assume that you wish to cool down the cockpit. To demonstrate, please set the cockpit zone selector to cold. You have demanded a cockpit zone temperature of 18 degrees Celsius. Because a low temperature has been demanded, the respective trim air valve closes and the cool pack output feeds the cockpit zone. Note that each increment on the zone temperature selector scale is 2 degrees, which gives a selectable range from 18 degrees at cold to 30 degrees at hot. In situations with a low number of passengers, the pack flow selector can be set to low. This has the effect of reducing the bleed demands from the engines and will therefore save fuel. On the engine warning display, Pack Flow Low memo is displayed in green. Occasionally, with a full passenger load and high ambient temperatures, it may be necessary to select high pack flow and cold to reduce the cockpit and the cabin temperature. Using high pack flow will increase the bleed demand from the engines and use more fuel. Once airborne, the pack flow selector should be returned to normal and the temperature selectors adjusted as required. After landing and engine shutdown, the system can be set to run from the APU or switched off completely. Or an external conditioning unit can be connected via a low-pressure connection point on the underside of the aircraft. The low-pressure air is fed to the mixing unit and then into the 4 zones. There are no indications in the cockpit to show that an external conditioning unit is in use. You are about to start engine 1 while a last payload change occurs. The APU is supplying bleed air. Normally, during engine start, the ECAM engine page is displayed. For training purposes, we have called the ECAM bleed page for you. Start engine 1 by clicking on it. Engine 1 is running as indicated on the ECAM bleed page and on the engine warning display, read the title of the failure. The ECAM caution Pack 1+2 fault with packs inhibited by doors appears amber because at least one door is not closed. The 2 pack flow control valves will remain closed, cross-line amber, as long as a door is open. This is done to prevent the packs from pressurizing the aircraft with one door open. Note, on the air panel, the amber fault lights in the pack 1 and 2 push-button switches are not illuminated. After review and confirmation from the pilot flying, clear air. As you can observe on the status page, packs 1 and 2 are indicated in amber in the inoperative systems column. After review and confirmation from the pilot flying, clear status. ECAM action completed. You are now the pilot non-flying and currently flying at your cruise flight level. Everything is normal. This is a demonstration of a Pack 1 overheat in flight. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. The ECAM caution, Pack 1 overheat, appears amber, meaning that an overheat has been detected in Pack 1. The ECAM bleed page is automatically called. Observe that the pack flow control valve has closed, cross-line amber. This occurred automatically when the overheat was detected to protect the pack from damage. The compressor outlet temperature has also turned amber because the temperature limit has been exceeded. and high flow is automatically selected on the remaining pack. On the air panel, the Pack 1 fault light is illuminated amber to help you locate it and to indicate the overheat condition. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. When Pack 1 is turned off, the off light illuminates white in the Pack 1 push-button switch. But notice that the fault light is still on because the overheat is still present. The next step in the procedure is a condition. When? Before doing the next action, we will have to determine if the pack overheat is no longer present. After review and confirmation from the pilot flying, clear air. As you can observe on the status page, the condition is repeated, and Pack 1 is indicated in amber in the inoperative system column. After review and confirmation from the pilot flying, clear status. ECAM action completed. Later on, you are still in cruise. Normally the ECAM cruise page is displayed, but for training purposes we have called the bleed page. You observe that on the air panel, the fault light in the Pack 1 push-button switch has extinguished, and the compressor outlet temperature indication is green. So we can conclude that the overheat is no longer present. Therefore you can turn Pack 1 back on. Switch on Pack 1. Everything is now back to normal, and the pack is reset. Now let's see other pack abnormal indications that you can encounter. You are in flight, and the air cycle machine of Pack 2 has failed. In this case, a bypass valve opens automatically, allowing the air to bypass the air cycle machine. The bleed air is now cooled by the heat exchangers only. Notice that on the ECAM bleed page, the bypass valve is indicated by a green arrow. And on the engine warning display, the amber message confirms that Pack 2 is operating in bypass mode. Note, on the ground, with an air cycle machine failure, ECAM will advise you to switch the affected pack off to avoid an overheat. Click on the forward arrow to continue. You are still on the ground, and this time both channels of the zone controller have failed, as indicated on the engine warning display. On the ECAM conditioning page, observe that Pack Reg appears in green, meaning that the temperature is regulated by the packs only. The packs deliver a fixed temperature of 5 degrees Celsius. Pack flow and temperature selections are lost, and all temperature indications are also lost. Click on the forward arrow to continue. Pack low flow indication pulses green when there is not enough flow from the packs to reach the selected temperature, as transmitted from the zone controller. We will finish this module by presenting the failure of a cargo isolation valve. Click on the forward arrow to continue. You are in cruise, everything is normal. This is a demonstration of a cargo isolation valve failure. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. The ECAM caution forward cargo isolation fault appears amber, meaning that the ventilation is lost in the forward cargo compartment because either the inlet or outlet isolation valve is not in the selected position. On the cargo air conditioning panel, the amber fault light is illuminated to confirm the disagreement of the valve. Also notice that no ECAM page is called. After review and confirmation from the pilot flying, clear conditioning. As you can see on the status page, the inoperative systems are the ventilation and the temperature control of the forward cargo compartment. After review and confirmation from the pilot flying, clear status. ECAM action completed. The conditioning of the air in the forward, aft and bulk cargo compartments is fully automatic and is very similar. So we will look at the operation of the forward compartment and see the differences for the other two. Ambient air from the cabin area enters the forward cargo compartment via two inlet isolation valves. The air is extracted from the aircraft via an extract fan and an outlet isolation valve. To decrease the compartment temperature, the cabin ambient air is mixed with cold air from the packs via a cold air valve. This valve has three positions to adjust the quantity of cooled conditioned air. The cargo ventilation controller controls the inlet and outlet isolation valves and the extraction fan. To provide compartment heating, hot bleed air is supplied via a trim air valve. The operation of the cargo trim air system is very similar to the trim air system for the air conditioning system. Note: compartment heating is not available when the forward cargo door is open. The air conditioning for the aft cargo compartment is very similar to that of the forward cargo compartment, except that no heating is available. For the bulk cargo compartment, only one inlet isolation valve is fitted, and the heating is performed by an electrical fan heater. Note: compartment heating is not available when the bulk cargo door is open. Let's look at the ECAM conditioning page to see how information on the cargo conditioning system is presented to the pilots. The cargo heating system is an extension of the air conditioning system. Hot air is routed from the trim air system for the forward cargo compartment and via an independent fan heater for the bulk cargo compartment. A cargo air conditioning panel on the overhead panel contains the controls for cargo heating and conditioning. There is an isolation valve push-button switch for each cargo compartment. These push-button switches normally remain in their lights-out auto position. When in this position, the cargo ventilation controller automatically controls the isolation valves and the extraction fan. Note: the isolation valves and the extraction fan are not represented on the ECAM page. For the forward cargo compartment, a cooling selector adds cold air to the ventilation air by controlling the cold air valve. Final temperature adjustment is achieved by the temperature selector, which controls the trim air valve. The hot air push-button switch is normally in the lights out position, on. It operates the fan heater for the bulk cargo compartment according to the temperature selector position. For normal operation of the cargo conditioning system, the only pilot inputs that are required are to confirm that each push-button switch is in its normal lights-out position, to set the required temperatures. Note that the mid position of the temperature selectors is approximately 15 degrees Celsius. Refer to the cabin air conditioning abnormal operation module for the abnormal operation of the cargo system, as both systems are very similar.